Today we are going to be assembling this 4-chip computer. Runs full 8K basic, and if you it's the 8052 AH basic computer. You could Google Micromint or just 8052 AH basic to get all the documentation on all the basic commands and everything. But it is a full 8K version of basic with floating point, sine, cosine, etc. All right, buckle up, everybody. Here we go. Okay, today we are going to build my 8052 computer with basic 52 interpreter. The finished product's going to look like this with the chips added. Currently, it looks like this. You've got the board. You got the microcontroller, which is the CPU, and the internal ROM. It's got 8K basic installed as well. 32K of RAM, your latch, and your RS-232 chip, and the appropriate sockets. You've got for your charge pump 1, 2, 3, 4, 5, 1 microfarad caps that jack up the voltages from TTL to RS-232 levels. Let's see, you've got the 470 microfarad cap that is its purpose is to smooth out the power supply, make sure there's no it's not noisy. You've got 3 100 microfarad caps. One of them is for the reset circuit, and the other two are paired with the LM7805, which is going to take your 12 volts from this barrel connector to the 7805 and convert it to 5 volts. Or it could be 9 volts. Doesn't matter. Anything over 7 volts, but it's going to drop it. It's going to drop the voltage down to 5 volts, which is the voltage that these machines talk on. This is your RS-232 connection, a green LED, a red power LED, three decoupling capacitors that are paired with 3 of these chips, and they're just there to again smooth out any noise on the line. You have a crystal, which is 11.0592 megahertz, and 233 picofarad caps to pair with that. You got a 1K, a 10K, and two 330 ohm resistors. All right, so that's it. And then once this is built, I will oh, and also it's not here. Where is it? Okay, yeah, I'm sorry. Include this in the list. An RS-232 cable, and when this is built, we will connect it through TerraTerm, if you like, or Putty, or whatever connectivity software you prefer on your Windows or Linux machine. We'll just pair it up, and I will demonstrate this working. You will have full 8K basic at your fingertips. That includes floating point and a whole bunch of features. So I'm just going to start assembling this, and starting with the smallest components first. A couple of things that you're going to need to know with the caps, because they're not well labeled on the board, is the charge pump caps are all 1Ks. Oh, sorry, one microfarad, and that's C16, C1, C10, C9, C2. Of course, the longer pin is positive. Shorter pin is the negative. Again, I made the mistake of putting the tall components on before I put on the short components, but whatever. Let's see. These sockets will be. Also, if you look, I have a tiny little chevron pointing to pin 1. Yeah, you can see it right there. A little chevron pointing to pin 1, which is also, you know, the pin that's got the, you know, it's going to show the indentation. So you get the orientation right of the chip. So that's, you know, when you put the socket in, doesn't matter if you put it in backwards because it's just a socket, but you have that. Let's see, this is a 100. So Charlie's, let's see, for reference, yeah, C7 is a 100. And C6 and C5 are 100s. And apologies, but C8 is the larger 470 microfarad head. But it's on the silk screen it was a smaller footprint, so it'll fit. See, fits just fine. It's just the cap, sometimes 470s are kind of chubby. Let's see, that's not going to interfere with, otherwise I'll have to dig around for another. Nope, the socket went in just fine. They are not going to bump into each other. The decoupler, again, purpose of a decoupler, they usually will go across at the closest point possible of the positive and, you know, the VCC and the ground of any of these chips, and it can make a huge difference in the reliability of your whatever circuit you're building. Not having them makes weird things happen, like it works 1 minute and then it doesn't and all that. Add the decouplers. A lot of times with your Arduino projects and stuff, they don't work with decoupling capacitors because those projects really aren't meant to be they're not meant to be well, they're there for educational purposes. They're not really meant to be robust, but you gotta have decouplers. I've seen a bunch of Z80 computer kits and stuff that have been made and they don't have decouplers, and I don't know why. Okay, here goes the crystal. In fact, one Z80 kit that which is a Tech 1 that I have a couple of boards coming through. I'm going to build a kit out. The one that I built did not have a decoupler on well, it had very few decouplers, and it didn't have one on a particular chip that every time my finger got near it, the whole computer would just crash just from the proximity of my finger. And until I put had to jury rig a decoupling capacitor on the back of the board, and as soon as I did that, the problem was solved. Let's get this in there. Okay. The green is going to go to the blink. Green LED goes to blink, and again, the side with the flat side is the cathode, which is the shorter pin. Same thing with the power. Cathode is the shorter pin. LM7805 is on. We'll do the same thing I did on my other project where we just put a big ass dab of solder on there. Alright, so everything's in. I'm going to stop the filming. I'm going to solder it all together and come back. Hold on. I'm still soldering, but I thought I'd let tape roll for a bit. A couple of points I want to make. This is a microcontroller, not a CPU. Of course, it has a CPU in it, but the microcontroller also contains, you know, some RAM, ROM, and an EEPROM internally on the 8052, and And most of your computers, your 6502s, your 486s, your Z80s, all these 88, all these that are just a straight up CPU, they are a von Neumann machine, meaning that the RAM and the ROM are all addressed the same. So if you have 16 address pins, like you would have on a Z80 or most 8-bit processors, if you had 16 address pins, you could address 32,768 bytes, and that's all you can address. So your RAM, if you had 8K of ROM, that would be addressable memory, and that would be 8K less RAM that would be available for use, because the ROM and the RAM can't share. Because they're sharing the same address space, they can't code. Anyway, your 8K ROM is addressed the same as the RAM. On this machine, which is a Harvard architecture, which most microcontrollers are, it has an internal ROM. In this case, it's got an internal EEPROM, which I programmed with the 8K BASIC. But and they're addressed internally on a different bus. What does that mean? Well, it means that when you're peeking and poking at your memory addresses, you need to understand that, in the first place, in this version of BASIC, peek and poke is completely different than what you're used to. So there are basically 3 commands: one for reading what your ROM, what's in your ROM memory, and then one for reading what's in your RAM memory, and one for what's where you can make changes to your RAM memory, which would have been a poke. Anyway, this is all well documented in the literature, but if you just Google 8052 AH BASIC, you should come up with their a pretty comprehensive list of all the commands in BASIC. So again, this is a microcontroller, and it's from the 8031 series of microcontrollers. Even though it's an 8052, uses the same command set. The only difference between that and 8052 and 8031 is this has internal ROM, and the 8032, the ROM, again, is Harvard architecture, but it's actually physically outside of the DIP. So you would have to have an additional ROM chip. And you'll find these 8052 microcontrollers embedded in a lot of keyboards, which I think is a total waste of its power. But I guess it's something that was popular for a lot of industrial controllers, a lot of EEPROM burners, and all that would use an 8052. It's it was in its day. Well, they're still produced today, but in its day it was pretty cool. There was a computer article with 8052 AH, which is very, very. This is basically this is a recreation of, in a way, at least pays homage to. It was called the Micromint computer, but so a lot of the this would be very similar to a Micromint computer in terms of its functionality, and its chip count and everything. So if you look at this is going to be a basic computer that will plug into your RS-232 port, anywhere, terminal, and it's going to run full basic, not tiny basic, on 1, 2, 3, 4 chips, which is really 3 chips, because the RS-232 is an add-on, because because this has a built-in UART anyway. You could go straight. You don't have to have RS-232. You could just go straight TTL to TTL if you wanted to. So it's a 3-chip computer, and one of the chips is a latch. So super easy design. Anyway, I got this little row to do. We'll finish up. Hold on. Mm-hmm. Okay, she is assembled. Hold still so you can get a good focus on that. And while you weren't looking, I assembled 3 more, because if you're going to do one, you may as well do multiples. Anyway, here she is. If you do have any issues with this at all, the first thing I would look at would be this USB cable that I ship with it. These are super cheap cables I got a couple years back from China. I can't remember. They were, $1.50 each or something like that. If there is a problem, I would look there first. And if you need to, a proper RS-232 USB adapter cable is like $9-10, so on Amazon. But I believe the one I shipped with yours was tested, so it should be fine. Anyway, without trying to get you car sick, I am going to try to switch cameras and see if we have any luck here. Hold on. Okay, so we're recording. Observe we're in real term. Port 7. It doesn't, whatever port your computer says it is. Let's put it on 9600 baud. In real term, you want to just use ANSI instead of ASCII. Again, go back to that. Hit the change button. All right, I'm going to apply power. Hit the space bar to set the baud, and you now have a computer. Print 22 divided by 7. You have a floating point computer. You know, this is full 8K basic with, you know, do while loops and you know, all your sines, cosines, and everything like that. So you know, this is a pretty powerful version of basic, and it's all run on a 1, 2, 3, 4 chip computer. Not bad. There you go. Hold on. Can't go wrong with that. Hello world. All right, man. There you go. There's so much you could do with this.